Okay, so I want to look at some of the exercises from 1.79 and try to figure out whether they're injective or surjective or bijective, or maybe none of those. So the first one, this is example 1. So L of xy is equal to x times 1, 0, 1 plus y times 1, 2, 0. Okay, so first, notice that this is a linear transformation going from R2 to R3. Okay, so it can't be surjective. Okay, but it can't be surjective because if a surjective transformation cannot go from a smaller space into a bigger space. So right away, we know it's not surjective. We'll see another way that it's not surjective. The matrix for this linear transformation is 1, 0, 1, 1, 2, 0. Okay, now it should be clear that these two vectors, the columns of this matrix, are linearly independent, so that tells us it is injective. But here's a procedure that you do for every problem. You row reduce it to get into row echelon form. So I need to swap the second and third rows. Okay, I'm going to subtract row 1 from row 2. Now I'm going to add 2 times row 2 to row 3. Okay, and finally I'm going to multiply row 2 by minus 1. Okay, so no free variables. So it's injective. Okay, and see the video on injectivity to see why that means it's not injective. You're going to have to know why that means it's not injective. Row of zeros. So not surjective. And it is L applied to the vector xy is equal to x times 1, 0, 1 plus y times 2, 0, 2. Okay, so again, it's going from R2 to R3, so we know right away it's not surjective. But let's just do the thing that we do. So we're going to put this into a matrix, and we're going to row reduce. So the first thing that I'm going to do is swap row 2 and row 3. Way to do it, but I just want to do the algorithm that I gave in my book so there's no confusion. Okay, so I'm going to subtract row 1 from row 2, and I got zeros here. Okay, there are free variables. So not injective. There is a row of zeros. So not surjective. Okay. Now I want to look at, let's see. Now I want to look, I just scrolled away, sorry. Now I want to look at example number 4. So L applied to the vector xyz is equal to x times 1, 0, 1 plus y times 1, 2, 0 plus z times 2, 2, 1. Okay, so it's going from R3 to R3. So we can't tell right away that it's not injective or not surjective. So we're just going to do the row reduction thing. 1, 0, 1, 1, 2, 0, 2, 2, 1. We're going to do the row reduce this, get it into row echelon form. If there are free variables, it tells us it's not injective. If there is a row of zeros, it tells us it's not surjective. Okay, if there are no free variables, it is injective. If there is no row of zeros, it's surjective. Okay, so the first thing that I'm going to do is swap the second and third rows. So this is 1, 1, 2, 1, 0, 1, 0, 2, 2. Okay, and now I'm going to subtract row 1 from row 2. So this is 1, 1, 2. 1 minus 1 is 0. 0 minus minus 1 is 1. 1 minus 2 is minus 1. 0, 2, 2. Okay, so now what I'm going to do is I'm going to add 2 times row 2 to row 3. So this is 1, 1, 2, 0, minus 1, minus 1, 0, 0, 0. And then I'm going to multiply row 2 by minus 1. This is not necessary at this point, but I want to get it into row echelon form. Okay, so there are free variables. The third variable here is the free variable. There are free variables, so not injective. There is, I guess I should say there is a free variable and there is a row of zeros. So not surjective. Okay, so there is a free variable, there's a row of zeros, so it is not injective and it's not surjective. Okay, so if you have a transformation going from Rn to Rm, if you have a transformation going from Rn to Rn, so the domain and the codomain are the same, either it's going to be injective and surjective, or it's going to be neither one of those. This is like how a set of in vectors in Rn, it's either going to be a linearly independent set and a spanning set, or it's going to be neither one of them. Okay, and again, watch my previous videos on injectivity and surjectivity to see how all of those relate. Okay, this is question number 6. So L applied to, this is going from R4 to R3. So L applied to x1, x2, x3, x4 is equal to x1 times 1, 0, 1 plus x2 times 1, 2, 0 plus x3 times 2, 2, 1 plus x4 times 3, 4, 1. Okay, so the matrix for this linear transformation is 1, 0, 1, 1, 2, 0, 2, 2, 1, 3, 4, 1. Okay, so remember, so notice again that it's going from R4 to R3, so it cannot be injective. Okay, if it's going from a bigger space to a smaller space, it cannot be injective. And we'll see that again when we have free variables, when we row reduce. So we're going to row reduce, and the first thing that we're going to do is swap the second and third rows. So this is 1, 1, 2, 3, 1, 0, 1, 1, 0, 2, 2, 4. Okay, the next step, I'm going to subtract row 1 from row 2. So this is 1, 1, 2, 3. 1 minus 1 is 0. 0 minus 1 is minus 1. 1 minus 2 is minus 1. 1 minus 3 is minus 2. And then 0, 2, 2, 4. Okay, and without writing everything down again, I'm just going to multiply the second row by minus 1, which means erasing these negative signs. Got too much on that one. I think that was a 4. That was a 2. Good thing I checked. Okay. And so now what I'm going to do is subtract 2 times row 2 from row 3. So this is 1, 1, 2, 3, 0, 1, 1, 2. 0 minus 0 is 0. 2 minus 2 times 1 is 0. 2 minus 2 times 1 is 0. 4 minus 2 times 2 is 0. Okay, so this is in row echelon form. And the second or the third and fourth columns are pivot columns, or sorry, free variable columns. So there are free variables, so not injective. There, which we knew already because this going from a smaller dimensional or bigger dimensional space into a smaller dimensional space, there is a row of zeros, so not surjective. A similar example, this is again is going to be a linear transformation going from R4 to R3. And it is given by x1 times 1, 0, 1 plus x2 times 1, 2, 0 plus x3 times 2, 2, 1 plus x4 times 2, 2, 0. Okay, so now the matrix for this transformation is 1, 0, 1, 1, 2, 0, 2, 2, 1, 2, 2, 0. Okay, and again, the first thing that I'm going to do is swap the second and third row. just so that all of the pivots are to the left or underneath the pivot in the row above it. Okay. Next, I'm going to subtract row 1 from row 2, so the top row stays the same. Notice this is a similar matrix to the one in the previous problem. 1 minus 1 is 0, 0 minus 1 is minus 1, 1 minus 2 is minus 1, 0 minus 2 is minus 2, and then this is 0, 2, 2, 2. Okay, and again, I'm going to multiply the second row by minus 1, so that's going to go away. This 1 is going to be 1, 1, 2. Okay, and now I'm going to subtract 2 times the second row from the third row. So this is 1, 1, 2, 2, 0, 1, 1, 2. 0 minus 0 is 0. 2 minus 2 times 1 is 0. 2 minus 2 times 1 is 0. 2 minus 2 times 2 is minus 4. Okay, in editing, I realized I made a mistake. That minus 4 there should be a minus 2. That is not a minus 4. That should be a minus 2. And now back to what I was doing.
Now I'm going to go ahead and divide the third row by minus 4 just to get it into row echelon form. Okay, so this is in row echelon form. The first column, the second column, and the fourth column are the pivot columns, and then the third column is going to be the free variable column. So there's a free variable, so not injective. There are no row of zeros. So it is surjective. Okay, and hopefully you're seeing now that in order for a linear transformation to be bijective, it has to be going from Rn to Rn. Okay, hopefully you've seen that before I had to say it. If not, that's fine. You might not have thought about it. Okay, let's look at one last example. This is going from R3 to R3. L of xyz is equal to x times 1, 0, 1 plus y times 1, 2, 0 plus z times 2, 2, 0. Okay, so again, the matrix, or not again, but similarly to what we've been doing, this is 1, 0, 1, 1, 2, 0, 2, 2, 0. Okay, and we want to make sure that the pivots are to the left or underneath the pivots in the row above it, so I want to swap row 2 and row 3. 1, 1, 2, 1, 0, 0, 0, 2, 2. I'm going to subtract row 1 from row 2. So this is 1, 1, 2. 1 minus 1 is 0. 0 minus 1 is minus 1. 0 minus 2 is minus 2. And then the bottom row stays the same. And again, I'm just going to multiply row 2 by minus 1. So the entries are going to be 1, 2. Okay, and now I'm going to subtract 2 times row 2 from row 3. So this is 1, 1, 2. This is 0, 1, 2. 0, 2 minus 2 is 0. 2 minus 2 times 2. 2 minus 2 times 2 is going to be minus 2. Okay. I'm going to divide row 3 by minus 2, so this is now going to be 1. Okay, so this is in row echelon form. It's in row echelon form. There are no free variables, so it is injective. There's no row of zeros. So it is surjective. So, since it's both injective and surjective, this means it is bijective. Okay, so I hope you have gotten something out of this video. When trying to tell whether or not L is injective, surjective, here are the steps. 1, find the matrix for L. 2, row reduce. 3, to get it into row echelon form. It has to be in row echelon form to do this. And 3, analyze. So what this means, this is like step 3.1. If there are free variables means not injective. Step 3.2 would be row of zeros. Means not surjective. Okay, so that is the outline for how to determine whether or not a matrix is injective or surjective. And notice it is very similar to how you figured out whether or not a set of vectors were linearly independent or a spanning set. Okay, so that's all that I have for this video.